In this video we're going to look at transforming graphs, and in particular transforming trig graphs. So the first thing we need is the three basic trig graphs. So here you can see the graph of sine x, and it goes from minus 360 to plus 360. You need to learn it within that range. You could just be asked to draw this half of it. You could even just be asked to draw this half of it, or you could be asked to draw between minus 180 and plus 180. So make sure you can do anything basically. So if you learn the graph from, where did it go to? If you learn the graph all the way from minus 360 to 360, you'll be grand. The next one is a cos graph. It's the same graph as a sine graph. It's just been shifted over a bit. And it goes from, starts at 1 when x is equal to 0, and it goes down to 0 at 90 and so on. So on your calculator, if you forget what these look like, you would just put in the key points. So just do like sine of 0, sine of 90, sine of 180, sine of 270, sine of 360. And both of these ones go from 0 to 1. Same for the cos. Put in 0, 90, 180, 270, 360. See what the values are. Very easy to plot. And the next one, and really you need to learn this, when you're drawing the tan graph, the first thing you would do, you would draw on the asymptotes. So the asymptotes are these lines I'm going to highlight. So the first one's at 90 degrees for a regular tan graph, and then every 180 before or after that. So 270, or else back the way, minus 90 and minus 270. So an asymptote is a line which the graph gets infinitely close to, but will never actually touch that. And notice as well, the graph shoots up to infinity, so it doesn't just go to 1 and minus 1, and that's how your graph looks. So it starts at 0, it's at 0, and then at 180 it's back at 0, and at 360 it's back at 0, and at minus 180 it's back at 0, and then it has that sort of shape, and it just repeats itself every 180 degrees. So you just got to learn how to draw it. Okay, we're going to look now at the transformations. Okay, so if you've got a basic graph of y equals f of x, if it's drawn, then first one, y equals f of x plus a. What it does, it moves the graph up a units. Y equals f of x minus a, moves the graph down a units. Y equals f of x plus a. Now this plus a is inside the bracket. So plus a, I would think it would move it to the right. But if it's inside the bracket, it's a bit of a pain. It doesn't do what you would expect, so it moves it left. That's an easy way to think about it. And the next one, f of x minus a, I would think it would move it left. It's inside the bracket. It's a bit of a pain, so it moves it to the right. And then again, outside the bracket, so it's in the vertical. So a times f of x, what that does, it stretches it vertically, scale factor equal to a. F of ax stretches it horizontally, scale factor 1 over a. And then the ones with the minus signs are reflections. So this minus here is outside, that means it's in the vertical plane. This minus is inside, that means it's in the horizontal plane. We're reflecting. So that means the first one means you're reflecting on the x-axis, but that means reflecting vertically. The next one means you're reflecting on the y-axis, but again that means horizontally. Okay, going to look at 3 examples. First one says sketch y equals sine x plus 2. Now I'm not very quick at these, so what I would do in a question like this, I would draw what y equals sine x looks like on minus 180 to plus 180. You can see I've done this here. That's my sine x from minus 180 to plus 180. So this thing here, really, you could write this as that's your f of x plus 2. So if sine is your f of x graph, then all we're doing plus 2 to it, from these rules above, which you need to learn, is moves it up by 2. So all of these key points, we'll do them all one at a time. At 0, moves up 2, it's now going to be up at 2 here. At 90 you're at 1. That'll now move up to at 90, you're at 3. At 180, you're at 0. So move that up by 2, you're now going to be at 2. At minus 90, you're at minus 1. Add 2 to that, you will be at plus 1. And at 180, you're at 0. Add 2 to that, you'll be at plus 2. And then you can just link that up again. It's a nice same shape. And there you have it. Done. Okay, 2 more to go. Next one. Sketch y is equal to 3 cos x. So that really is the same as 3 f of x. So if your cos is the f of x graph, 3 times f of x stretches it vertically, scale factor equal to 3. So again, I've drawn my cos graph from minus 180 to plus 180, and that's what it looked like. And then again, I'm going to do my key points. So this is a wee bit different here. At 0, I'm 1 unit away. 3 times 1 takes me to 3 away from my x-axis. This point here is on my x-axis, so it stays on the x-axis. This point here is 1 below, so it now goes down to 3 below. This point is on my x-axis, stays on the x-axis. This point is 1 below, now goes down to 3 below. And then link that up. And you will see there we have y equals 3 cos x. So there it is, drawn out. I would just repeat in that fashion. So there's the two compared to each other, y equals cos x and y equals 3 cos x. Okay, tricky one now. Last one says sketch y equals tan of 2x. Now first of all, we're going to think about this as being f of 2x. So that is a horizontal stretch, scale factor equal to 1 over 2. So it's actually like a compression, so it gets squashed in. So before you do anything else, our asymptotes have to get squashed in as well. So our asymptotes are now, instead of being at minus 90, it's now going to be minus 45. And instead of being at plus 90, it's being plus 45. And then every 90 degrees after that, there will be another one. And then we will just do that then, so it gets squashed in. So then it's going to go like this, and then repeat again, and then repeat again. And there we have it done. So it's sort of been squashed in. So that's quite a tricky one. You can see but sorted asymptotes in. So there now, instead of every 180 degrees or every 90 degrees, and instead of the first one starting at positive 90, squash that in, it's going to be positive 45, and so on. And that is us done. Okay, I'm going to zoom back to the bit, very important bit for you to learn, which is these things here. So all of those wee rules there you really do need to learn.